Welcome, Form 4, AdMaths, Past Years, SBP. Topic, vector. Given the point A, 1, 2 and the point B, 4, negative 2. So we are given 2 points, A and B, with its coordinate. We are given coordinates. If vector OC same as 2 times vector OB minus OA. If you notice, all the 3 vectors are starting from O, which means it is position vector. Any vector that starts from origin O is a position vector. Part A, find the coordinates of point C. So as usual, we start part A. They are asking the coordinate of point C, which I label as XCYC. Since they are asking regarding point C, I will go to the information involving C, which is OC vector equals 2OB vector minus OA vector. Now, as I said earlier, all the 3 vectors are starting from origin O. So, all the 3 vectors are position vector. So, we need some notes regarding that, which is a position vector OD same as the coordinate D. So, if you have a position vector OD, we can get the coordinate D, and vice versa. If you have coordinate D, we can get the position vector OD. Example, let us say D coordinate XY. So the point D, we have coordinate XY. Therefore, the position vector OD is XY in the column vector. We also can write the vector OD XI plus YJ. So the important thing, from position vector of OD, we can get coordinate D, or from coordinate D, we can get position vector. So here, I have the position vector OC. As I said here, if I want to find the coordinate C, I just need the position vector OC. So I'm going to replace OB with the coordinate B, which was 4, negative 2. So here, the OB position vector, same as the coordinate B, which is 4, negative 2. And then, of course, minus. I put back the minus. And position vector OA, same as the coordinate A, 1, 2. Which I put here 1, 2. Okay, so now it would be easy. 2 I times with the 4 and negative 2. I'm going to get 8 and negative 4 minus the 1, 2 I copy back. So now I have 8 minus 1 is 7. And then minus 4 minus 2, I'm going to get minus 6. Now what we got here is the position vector OC. So the position vector OC is 7, negative 6. As I said earlier here, from the position vector OD, I get coordinate D. Therefore, from the position vector OC, I get the coordinate C, which is 7, negative 6. Next, part B. They ask us to find the magnitude of the vector OC. Of course, you need to remember the notes. For a vector AB in the form of AI plus BJ, the magnitude of the vector AB, Pythagoras theorem, is the square root of A square plus B square. And since from part A, we already got the vector OC from part A, which was in column vector 7, negative 6. And this 7, negative 6, of course, same as 7i minus 6j. A vector can be written in column or I and j. So since I have vector OC 7i minus 6j, therefore the magnitude of the vector OC is the square root of 7 squared plus negative 6 squared. Square root 7 squared plus negative 6 squared. This one use calculator. We use calculator. 7 squared plus negative 6 squared, you would get 85. So the magnitude of vector OC is square root of 85. Now before I leave, I like to remember and tell you that a position vector OD will give you the coordinate D. Okay? Reverse, from the coordinate D, I can get the position vector. Now let me give you one simple example. If I were to have the vector OE, position vector, 2i plus 3j, or I can write in column 2 and 3. So the coordinate E would be 2 and 3. Okay? So from position vector, either ij or column, I can get the coordinate. And reverse, I can do the reverse. If I have a point D, 7, 2, now the position vector OD would be 7i plus 2j, or in column form, 7 and 2. Okay, that's it. I see you on the next lesson.